other trigonometric functions, which really includes secant, cosecant, and tangent. Okay. So we will know 5 graphs total. We're probably not going to spend any time on cotangent. If we have time, we can talk about maybe what one would look like, but I'm not going to ask you to graph cotangent. Okay? So first of all, let's think of some prior knowledge. Turn to your neighbor. What do we know about secant and cosecant? All right. I'm hearing some excellent conversation. Just make sure you're using the correct vocabulary word. Okay, Michaela and Josie, what's the relationship? Thank you for using that word. They are reciprocals of each other. I've heard a lot of inverses. Inverse isn't the correct word. It needs to be reciprocal. I know that you know the relationship, but I want you to use the right word because next week we're going to talk about inverses and there's something different. Okay? So secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. Okay? You know that. Now, turn to your other neighbor. What does it mean? Yeah, your other neighbor. Okay. What is a reciprocal? What does it mean to be a reciprocal? Turn to your other neighbor and talk about it. Okay. Let's see. Pod 3. You guys are all one group, pretty much. What does it mean?
Like to flip the top answer and put it in the bottom and the bottom to the top.
Okay, so a fraction would be flipped. Yes. Okay. Some of you I overheard 1 over that number. Same thing. Okay. What's going to happen if we try to take the reciprocal of 0? Undefined. What would that look like graphically if we have an undefined value? Vertical what?
Vertical stuff.
Special kind of vertical line, we call them. Yes, I knew you would think of it. Okay? So graphically, when we have an undefined value, we're actually going to get an asymptote. Okay? So, are there places where secant and cosecant are undefined? Yes, there are. So secant and cosecant, they are going to have asymptotes in their graphs. Okay? So what we're going to do, we're going to take sine and cosine, and we are going to take the reciprocal to figure out what our parent graph looks like. So here we go. Here is the graph of y equals the sine of x. Sketch it very, very lightly. Now, when we have our frame, okay, I make you graph these points right here. Okay, and usually when you graph, you split your frame like this, right? Okay, just think about that. So where is the sine 0? Pi would be a place. And what happens when we take the reciprocal of 0? It's undefined, and we have an asymptote. Okay? Sine is also 0 at 2 pi, which means when we take the reciprocal, we get an asymptote. And here at 0, sine is 0, which means when we take the reciprocal, Yeah, it's okay. You want to turn the light
Oh, no, it's fine.
on? Okay.
Just keep doing what you're doing.
All right. So we have asymptotes, 0, pi, and 2 pi. Okay. Now, what is the value here? Okay, and what is our, but what's our y value?
1.
1. What's the reciprocal of 1? Okay, so that's a point on our graph. Now, at, let's say, pi over 6, our value is 1/2. What's the reciprocal of 1/2? Same thing here at 5 pi over 2. The sine value is 1/2. The reciprocal is 2.
Thank you.
You're welcome. So we have a little u in there, and it's going to approach the asymptotes. Same thing is going to happen here. There is the blue with the red asymptotes. That is your y equals cosecant. Okay. So what's going to happen is if we know what the sine graph looks like, we can just sketch in our asymptotes and our u's. Okay. Now, the domain of this, I'm not going to make you write because what's happening? We have asymptotes over and over and over again. So we have, between 0 and pi, and between 0 and 2 pi, and then between 2 pi and 3 pi, and I'm not going to make you write that. But, what would our range be?
All real.
It's only the blue. Excellent. Negative infinity to negative 1 and 1 to infinity. And we include negative 1 and 1 because we actually have points there. Okay. All right, let's talk about what secant looks like. So here's the graph of cosine. So we'll first start, these would be our 5 critical points, right? Where is the cosine 0?
0.
Pi over 2. So at pi over 2, we are going to have secant be undefined. So we have an asymptote. Where else is the cosine 0? 3 pi over 2. So the secant would be undefined at 3 pi over 2. Okay. Then things are going to go similarly. Okay? Here at pi, the cosine is negative 1. Well, the reciprocal of negative 1 is negative 1. And we can do the same thing. We have at 2 pi over 3, the cosine is negative 1/2. The reciprocal is negative 2. Same thing happens at 4 pi over 3. Okay, so secant and cosecant are going to look similarly. We just have our asymptotes at different places because sine and cosine are 0 at different places. Okay, now if this bothers you and you want to make the entire u, that's fine. If you make half the u, it's part of just that one period, I don't care. Alright, but I am concerned about where those u's are and where the asymptotes are. Okay, what I will expect, okay, so I'm still expecting you to label 5 critical points, okay? You're going to label this point right here, this point right here, and this point right here, and then you will label 2 asymptotes. So you're either going to label 3 points and 2 asymptotes, or 3 asymptotes and 2 points. Okay, so let's try one. Basically, we're gonna lightly sketch in what we would for a sine graph, and then graph in the reciprocal. Okay. Now, secant and cosecant do not have amplitude, but we'll instead just talk about A. What is A?
2.
Okay, well, A is -2, but when we graph our when we think about the sine curve, we know that the sine would have amplitude too. Okay? The period, what is the period? 2 pi divided by, what is B?
1.
Okay, so our period is 2 pi. Our starting point, what is our C value? Careful.
Negative.
-pi divided by B, comma D. So our starting point is really -pi, -2. Okay. So what I'm going to do is, anything I do in green, I would do very, very, very lightly on your paper. Okay. So here is -pi, -2. I'm going to draw up 2 and down 2, because if we were graphing sine, that would be the amplitude. And we're going to go over the length 2 pi. If I begin at -pi and our period is 2 pi, where are we ending? Pi. What's halfway between -pi and pi?
0.
What's halfway between -pi and 0? -pi/2. And halfway between 0 and pi? Pi/2. What? Okay. And then just very lightly, I'm going to sketch in my negative sine curve. You don't have to sketch in the sine curve, but for some of us it's going to help. Okay? Now, the asymptotes shift with our function, okay? And so anytime your sine or cosine curve crosses this middle dotted line, that's where our asymptotes are going to go. So we're going to have an asymptote here at x equals -pi. We're going to have an asymptote here at x equals 0, and then an asymptote here at x equals pi. Okay. Then we're going to take these points and create our U's. That's what I would expect you to label. Yes.
So when you want us to label things, you just want the like x equals -pi and x equals 0. I don't have the coordinate.
Yep. So you're still labeling 5 things. Just they're not all points. Some are points and some are asymptotes. Okay? If you can graph sine and cosine, can you graph secant and cosecant? Yes, yes you can. Okay. So what I'm going to do is we're going to talk about tangents, and if we have time, we'll come back to a secant curve. but it's really just about graphing sine or cosine, and wherever it crosses the middle, those are your asymptotes. Where it touches the top or bottom of the frame, those are your u's. Okay. So let's go and talk about tangents. We'll start here at 0. What's the tangent at 0? What's the tangent at pi over 4? What's the tangent at pi over 2? Undefined. So what's happening at pi over 2? Oh, we have a asymptote. Okay, so that we kind of hit, not a dead end, but we hit an asymptote. So let's maybe rotate, okay? We rotated it here. Let's rotate backwards now. If I rotate backwards to negative pi over 4, what's the tangent there? Negative 1. What if I rotate to negative pi over 2? What, Michaela? Undefined. So we have another asymptote. Talk about the shape in between. And it has to approach the asymptote, so it's going to keep on going forever and ever and ever. And then what's going to happen is this is going to repeat over and over and over again. But we're really just going to be worried about one chunk of it, just like we have been with sine and cosine. Now, this is the parent graph. What is the period? How long before we start repeating again? Pi. If I look where this asymptote is and this asymptote, okay, the asymptotes are where we're going to repeat over and over and over again. So there's only pi from negative pi over 2 to positive pi over 2. So something that's important to note is the period of tangent is pi. Okay. So let's talk about how that's going to affect what we find. All right. So you recognize this. This looks similar to what we did with sine, cosine, now cosecant and secant. What I want you to note though is there's no amplitude for tangent. Okay, we still want to identify A, and A is still going to affect whether it's reflected or not, but there is no amplitude. Okay. Another thing I want you to note is that the period, since the period of tangent is pi, we're going to calculate the period of other tangent functions using pi divided by b instead of 2 pi divided by b. Now, our framing method is going to be slightly different for tangent. Okay? Sine, cosine, secant, and cosecant, our frames are all the same. But tangent is going to be special. Okay? Right in the middle of our graph, is going to be our starting point. Okay. Then we'll have to draw our frame up A and down A. But then instead of putting all of our frame to the right, since we had to rotate up to pi over 2 and then down to negative pi over 2, what we're going to do is we're going to put half of our frame to the right and half to the left. Then when we split it into those quarter marks, that tells us where those 2 points go. Okay? So the edge of our frame will be our asymptotes for tangents. And then those quarter marks, the 3 marks inside will tell us where those points go. Okay? And then if it's reflected, we'll know that this would need to snake down instead of up. So we are going to graph. Are there any questions about the frame? Okay, when we go through an example, I'll talk through again about the frame. Okay, and I'll have you write some things down. Okay. So here's our example. Okay. The first thing we're going to do is plot the starting points. We find the starting point the same, C divided by B, comma, D. Okay. So Grant, what would our starting point be in this example?
0, 3.
Yep. Okay. So I'm going to plot the point 0, 3. Okay. Then we need to identify, we need to construct the frame from our starting point. So we're going to identify A. What is A? 2. It is not the amplitude, it is just A. We are going to construct our frame by going up 2 and down 2. So we're up to positive 5 and down to positive 1. Okay. Now we need to identify the period. How do we identify the period for tangents? Pi over B. And what is B in this case? Okay, B is 1. So if we say pi over B, then our period equals pi. Now, since our starting point is in the middle, we want half of our frame to the right and half of our frame to the left. So since our period is pi, I'm going to put half of it to the right, so that stretches to pi over 2, and then half of it to the left, so that would be negative pi over 2. So that our frame stretches the length of pi, we have half on the left and half on the right. Okay. So now I'll finish our frame here. What's halfway between 0 and pi over 2? Okay. And what's halfway between negative pi over 2 and 0? Okay. So we have our frame. Remember, the asymptotes will go on the edge of our frame, so I need to label this as x equals negative pi over 2. And x equals pi over 2. And then we want our 3 points. Okay, the starting point will always be 1, 0, 3. And then we want points on the edge of our frame. So this one would be at pi over 4, 5, because A was 2, it has to be 2 away. And then this one is at negative pi over 4, 1. Since our A was 2, that has a vertical distance of 2 away. And then we can snake through here. So there's one period of our tangent function. Okay? Now, since we have asymptotes that repeat over and over and over and over and over, I am not going to ask for the domain. However, I will ask for the range. Layton, what is our range? Okay, our range. Okay, so our range is all real numbers, and it will always be for a tangent graph. Now, we have about 4 minutes left, so I'm going to go back and do that secant example. Okay? We'll get through as much of it as we can. 903, we have something to say, right? Okay? So go ahead and write this one down. Okay. We'll identify A to be 1. Our period, we calculate 2 pi divided by B. What is B? 2. So our period is pi. Our starting point is is C over B. But what is C? Okay. C is negative pi over 2 divided by B is 2, comma D. So our starting point is negative pi over 4, 2. Okay. So we have our starting point. We'll go up A and down A. If we begin at negative pi over 4 and our period is pi, where do we stop?
5 pi over.
Not quite. 3 pi over 4. Because we're adding 1 pi to negative pi over 4.
Oh,
Okay? Halfway between negative pi over 4 and 3 pi over 4. What? Halfway between negative pi over 4 and pi? Did you run? Right. And halfway between pi over 4 and 3 pi over 4. Okay? So this is a secant, so I'm going to lightly draw in a positive cosine curve. Remember, I'm in green, so that means I'm being light. Anytime it hits this middle, that is where an asymptote is. So we have an asymptote at x equals 0 and an asymptote at x equals pi over 2. And then here is where we make our u's. So this is what I'm going to ask you to do. I'm going to show you what your homework is. I'd like you to leave your quiz corrections on the table for me, and I'll just pick those up as you leave. Okay? There you go. Yep. Oh, that would be a problem. Yeah, so keep them, put them together, quiz with your quiz corrections. If they're, since they're separate pieces of paper, don't worry about stapling, I'll just keep them together, okay? So just leave them on your desk and I'll pick them up.
You can't read it if